Welcome to Future Dr. NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 6 of 11th standard, System of Particles and Rotational Motion. And today is not problem solving session. This session is problem questionnaire session. That is 7 questions will be given in this session. Next session we will solve the solution for these questions. Let's move to question number 1. Find the torque about the origin when a force of 3J Newton acts on the particle whose position vector is 2K meter. Option A, 6J cap Nm, Newton into meter. B option, minus 6I cap Nm. C option, 6K cap Nm. D option, 6I cap Nm. Here you should know the relation between torque, force and position vector. By knowing the relationship, we can solve the solution for these questions. Let's move to question number 2. When a mass is rotating in a plane about a fixed point, its angular momentum is directed along dash. Option A, line perpendicular to the plane of rotation. B option, line making an angle of 45 degree to the plane of rotation. C, the radius. D, tangent to the orbit. Here you should know the direction of angular momentum, that is in rotation motion. So by knowing this concept, you can find the solution of this question. Let's move to question number 3. Two particles which are initially at rest move towards each other under the action of the internal attraction. If their speeds are v and 2v at any instant, then speed of center of mass of the system will be dash. A option 2v, B option 0, C option 1.5v, D option v. Here we should know the formula for speed of center of mass. By using that idea, we will solve this question. Let's move to question number 4. A solid sphere of radius capital R is placed on a smooth horizontal surface. A horizontal force F is applied at height h from the lowest point. For the maximum acceleration of center of mass is dash. A, h equal to r, B, h equal to 2r, C, h equal to 0, D, acceleration will be same. Here you should know the formula for, that is horizontal surface, that force with that height. By knowing the relationship, you can find the solution for this question. Let's move to question number 5. 4 identical thin rods, each of mass capital M and length small l, form a square frame. Moment of inertia of this frame about an axis through the center of square and perpendicular to its plane is dash. A option 4 by 3 mi square. B option 2 by 5 mi square. C option 13 by 3 ml square. D option 1 by 3 ml square. That is by knowing the formula for moment of inertia for thin rod, that is along the perpendicular to its plane, from the center and perpendicular plane. By knowing the formula, you can solve this question. Let's move to question number 6. The moment of inertia of uniform circular disc of radius capital R and mass m about an axis passing from the edge of the disc and normal to the disc is dash. A option 1 by 2 mr square. B option mr square. C option 7 by 2 mr square. D option 3 by 2 mr square. Here you should know the formula for moment of inertia of a circular disc. By knowing the formula, you can find the solution for this question. Let's move to question number 7. Angular speed of an engine wheel making 90 revolution per minute is dash. A option 1.5 pi radian per second. B option 3 pi radian per second. C option 4.5 radian per second. Last option 4 pi radian per second. Here you should know the relation between angular speed and then that revolution per minute means the frequency. By knowing that, you can find the solution for this question.